Cari is a professor of sedimentology and stratigraphy at the University of Utah, where she undertakes research from basin analysis to sedimentation. And today, Cari is going to talk to us about her presentation, Stuck in the Mud, Sediment Stories Revealed from the Glen Canyon Dam Experiment. So without further ado, over to you, Cari.
Hello, amazing. Thank you. Can you see the right screen and can you hear me?
Everything's perfect.
Oh, I don't believe it. Okay, hello everyone. So nice to see you, meet some new people and see some old friends. Today I'm talking about a field area in southern Utah. Let's see, let me have to do it like this. Okay, here we go. Glen Canyon and what is known as Lake Powell is a man-made reservoir that was created in 1963 following completion of the Glen Canyon Dam. And that is located right on the southernmost Utah, northern Arizona border right here. Um, Lake Powell is the second largest man-made reservoir in the United States after Lake Mead, which is the first. And that is located just downstream across a little feature called the Grand Canyon on the Colorado River. The Colorado River and this entire field area is massively important in terms of societal interests and geopolitical interests. The Colorado provides water for over 40 million people and is under kind of immense stress and pressures given growing population demands and shrinking water supply under regional drought conditions. There are also some interesting sort of intersectional lenses in terms of recreational use. The fact that this field area is located amidst all kinds of federal lands and protected lands and national parks and so on. It's also part of a hydroelectric power plant. And all of this is happening, and I entered this kind of research amidst the final days of the laws that govern the use of the river and the water, known as the Colorado River Compact, that was initially established in 1922, modified in 2007, and set to expire in 2026. And so, it's understandable that most of the interest in this area centers on water and water supply. Um, my role as a sedimentologist is to insert the acknowledgement and the fact that water brings with it sediment, and sediment is also an important part of the story. So I refer to this as a grand experiment, the Glen Canyon Dam experiment, because to a sedimentologist eye, we have wonderful instrumentation going back to the start and the initiation of the dam construction through today. And that instrumentation includes daily and sometimes multiple times a day measurements of water level at the dam. So a sedimentologist treats that as base level, sort of like a human scale and basin scale flume experiment or sandbox experiment. We also have fairly good records of sediment discharge along the main rivers that feed into Glen Canyon, going back to this initiation. And so if you look at the water level at the dam from 1963, you can see that it took over 10 years to fill and then kind of remained at this high stand through most of the 80s with a couple of precipitous drops. And that since 2000, basically, water level has been gradually falling down to a couple of years ago, almost minimum power pool for the hydroelectric plant. And today we're up here and expected to fall very low again this year as well. We also have, again, combined both Colorado and Green River river discharge over time plotted against that. And so in terms of the sediment story, this water history again is bringing in sediment, and some of our work previously has focused on mapping and coring and exploring the main plugs of sediment, which is in the two main river deltas, the Colorado and the San Juan. And so exploring that just a little bit further, here's a map that shows the Colorado River coming in, and then the other major tributary I'll talk about is the San Juan River coming in over here. This is a map showing the maximum reservoir inundation zone, which covered about 600 square kilometers upstream on the Colorado from the Glen Canyon Dam. And our work has basically followed both of these main river systems downriver to look at both where sediment is now perched and exposed, having been deposited in the 80s and now kind of stranded as water level has fallen, where we can see it. We've done some work on the deltas themselves. And then I'll show you a little bit of work, hopefully, from sub-bottom imaging down in the deep lake. One of the data sets that's really key for us is a set of cores. Over 400 meters of sediment core was recovered by the U.S. Geological Survey in 2018 from both the Colorado and the San Juan. And some of those cores go down to the pre-dam river sediment. And so we know we have a good, sort of marker point in 2018 of how much and what type of sediment was accumulated up until then. And since then, we've added on some of the rest of the story. And so the USGS estimated that almost 7% of reservoir storage capacity was lost between 1963 and this coring exercise in 2018. And now our work has extended that again to more recent. So again, we'll kind of move downstream in this talk, first off with the Colorado River. And our initial work began in the most upstream reaches of the maximum full pool level. So this is Waterhole or Calf Canyon that's located just below the maximum height of Powell in the 80s, which was 3,700 feet. And this is a remarkable pile of sediment in terms of some of the philosophical things that go through my mind. This is, 250 million year old river and lake sediment in the background, and here's 60-year-old river and lake sediment in the foreground. Remarkably thick. In terms of the sedimentology of these layers, which I go into in longer talks, there are beautiful sedimentary structures that tell us which of these layers are lake beds, which of these layers are delta deposits, and which are fluvial deposits. And so we've kind of assembled what I think is a nice story of the deposition of these layers over time. As it relates to this talk, a key part of this, and this is just showing our interpretation of how these layers were deposited. It's a very cyclic, kind of rhythmic looking pile of deposits. But in terms of this talk, a thing that we did here was very high precision surveying of the elevations of the lake beds in particular. And by modeling lake level history with the instrumentation that I mentioned earlier, we're able to basically project when exactly we must have had lake deposition at these different times. And so there are only certain times when these lake beds could have been deposited. And what we find by projecting that is that most of this 10, 15, 20 meters of sediment in some places had to have been deposited very quickly within just a few years. And to be honest, probably most realistically, just a few months within the 1980s for the most part. And so telling time in sedimentology is a holy grail. It's something that we always search for. And this was a wonderful realization to say, we think we can match specific layers to specific times. Moving to the San Juan, which is a very different river. Here's the Colorado again, and we were looking at a location that's just off the map here. And here's the San Juan. When we compare these two different rivers, we think that they had similar sediment discharge. Big asterisk there because our instrumentation on sediment load is terrible compared to water discharge. But we think probably similar amounts of water or of sediment discharge. But the Colorado is a much bigger river and carries, 75, 80, 85% more water proportionally. So the San Juan is a much muddier river, basically by comparison. And that gives us some interesting different insights into how this system works. Most of the San Juan work has really focused on the sediment cores that I mentioned earlier. And as relates to the idea of timelines and just kind of saying the story of what actually happened during deposition of the story or deposition of the sediment, An interesting thing that's come out of the San Juan cores is that we can see seasonal, almost daily cyclicity against a longer term wavelength of these decadal base level controls as reservoir level has gone up and down. And that's a story that's told through both the lithology and the sediment geochemistry that we have measured. And just to put it very, very briefly, we see regular signatures of seasonal snowmelt in the spring that is then followed by distinctive signatures of summer monsoons when the North American monsoon system gets set up. And you see that sort of over and over again. But again, for a sedimentologist to be able to um, read into almost daily or monthly level controls versus the broader base level control, which is shown here at decade scale, that's a really powerful thing to be able to do. So I know I'm going through this very quickly, but we have, just like with the Colorado outcrop example, we have marker beds within these sediment cores that we can link to specific years. In some cases, for the San Juan, they link to specific known tailings and mine spills from the upstream mining districts in the San Juan Mountains. And again, we are now working on being able to sort of correlate these sections throughout both rivers. Again, telling time in the sediment record. Getting back to the deltas, this is a mesmerizing set of videos, and I know I'm sort of running out of time, but this shows the dynamic nature of the deltas from 2018 to 2023. We're just looking at monthly images that show these slugs of sediment that are the deltas moving in and out over tens of river kilometers in just a few months. And so we know that over these short time scales, it's an incredibly dynamic system. I couldn't help myself. I had to put this in here. There are also flaming mud volcanoes in the upstream delta portions that are related to biogenic gas that is, basically microbes eating the vegetation right after it's deposited, which has been an incredible thing. And methane in reservoir systems worldwide is known to be an issue. So on the deltas side of things, what we're focused on is measuring these rates of motion. And we're finding some interesting things in terms of the relatively slow progression under lowering lake levels versus the rapid progressions under transgression or rising lake levels. But the last thing that I just want to end on is looking at the last sort of 5 to 7 years, we think we're seeing an increasing rate of motion and just a change in the pace of sedimentation in the reservoir. And that is likely linked to remobilization of these perched reservoir sediment, 60-year-old sediment, now being sent back down into the deltas. And you can see some spectacular examples of just how sediment fails and re-entrains and enters the system here. And just mindful of the time, I'll go quickly, but this is a particular sediment slump that happened last November that we think actually temporarily dammed the entire Colorado, which is a remarkable thing in its own. So I'm going to just jump ahead and say, in terms of the deep lake sediment record and thinking about where is all of that remobilized sediment going, we're working on bathymetric and sub-bathymetric surveying of the lake floor and the layers of sediment below, and there's some cool images of that here. But what we're seeing is that if we correct for the fact that lake level has changed over time, we're seeing the lake floor come up as you would expect. What you might not expect is that in the last 7 or 8 years, we think we've doubled, tripled, maybe even quadrupled the rate of sediment deposition in the lake compared to the previous 50, 60 years of this reservoir's history. And I think that's because it is essentially cannibalizing and regurgitating its own reservoir sediment further and further downstream. So I apologize for going so fast and still being over, but these are some of the key takeaways, some of which I've talked about and a lot of which I haven't. But most importantly, Thanks to everyone that's contributed to this. It's a group effort, and I would love to chat more. If anyone's interested, here's my email address, and I'll stop.